We can extend the shell method to regions that are revolved about horizontal axes. In this case, we're going to look at an example where it's revolved around the x-axis. In this case, we're going to be integrating with respect to y. The formula is very much the same. Volume is going to be 2 pi times the radius times the height. The only difference is that the interval is going to be on the y-axis, and we're going to, like I said before, we're going to be integrating with respect to y. So in this case, we are given x equals y squared as our curve. It says it's bounded by the x-axis, the line y equals 4, and again, we're revolving it around the x-axis. The interval of integration, these are going to be y values this time. It's going to go from 0 to 2. Then it's 2 pi times the radius. So the radius is going to be the distance from a point on the curve to the axis of revolution. That's going to be our y value. So the radius is just y. The height is going to be this distance here in red. So to find the height, it's going to be the distance from 4 to this point here, which is y squared. So if I had to label these 2 points, this one here would be the point 4y. This point over here on the left would be the point y squared, y. So the distance is just right minus left value, 4 minus y squared. So that's going to be my height. We can integrate this one. I'm going to start by putting that 2 pi in front like I always do. Then I'm going to distribute the y, so I have 4y minus y cubed. Now I can integrate. I end up with 4y squared over 2 minus y to the 4th over 4. And we're going to look at that from y equals 0 to y equals 2. 4y squared over 2 is the same thing as 2y squared. We'll acknowledge that. I'm not going to take the time to rewrite everything though. Plugging in a 2 for y, so here again it's 2y squared. Since y is 2, 2 squared is 4, 2 times 4 is going to be 8. Minus 2 to the 4th over 4. 2 to the 4th is 16. 16 divided by 4 is 4. And at this point, I would subtract what I get when I plug in 0 for y, but those are both zeros. So I have 2 pi times 8 minus 4. That's 2 pi times 4, which gives me a volume of 8 pi. And one last example. We're going to take this curve here. It's x equals y squared, bounded by the y-axis and the line y equals the square root of 2. And we're going to find the volume of the solid generated by revolving this about the x-axis. Since we're revolving it about the x-axis, we're going to be integrating with respect to y. So our interval will go from 0 to the square root of 2. It's 2 pi times the radius times the height. In this case, the radius is the distance from a point, and let's look at this point right here, to the axis of revolution. And that distance is just going to be the y value of that point. This point here would be y squared comma y. The y value of that point is just y, that's my radius. The height, that would be the distance of this little red line segment here. Well, that distance is just the x value here of this point, which is y squared. If we bring that 2 pi in front, we're integrating from 0 to the square root of 2 of y cubed dy. That gives us y to the 4th over 4. And again, we're evaluating from 0 to the square root of 2. The square root of 2 to the 4th power is simply 4. So I have 4 over 4, which is 1, minus 0 to the 4th over 4 is 0. So it's 2 pi times 1, which gives me a volume of 2 pi.